someone presents something about 20 minutes. We prefer open-ended stories because we like to interact and to discuss. And we always ask someone to open the discussion with a few observations and a few questions. And from then it flows on interactively. We stop when there's nothing more to say or when the 60 minutes are over. That's quite simple. Because the population is changing a little bit, which I like a lot. We decided, we had some small conference on that, not to do round of introductions every time. That would take 20 minutes at least when everyone is very disciplined. But for that purpose, Emma has sent you in the invitation, also an invitation to give away a few details about yourself. It's completely, it's not mandatory at all. It's voluntary, but the idea is that when people see that Excel sheet, they can click on your personal page and discover who you are if interested. So it's all low key. We will add that file and update that file every time we send around the agenda from now on, I believe. And most of you, I believe all of you, have also added your name to your face on the screen, and that helps a lot already. No problem. So now, without further ado, we have Andreas Holst as a guest. I believe it's from Maastricht University. His master thesis supervisor seems to be Bram Dukes, quite familiar in this circle. And you have a really interesting topic on registered reports and also on detecting specific forms of bias in the domain of selective reporting in these registered reports as opposed to other types of reports. So Andreas, the floor is yours. Do what you like, share your screen, share with us your thoughts, and try to keep it in 20, 25 minutes if you can.
Mm-hmm. 1 second, I'm sharing my screen. Thank you for the introduction. A small correction that I'm still a bachelor student. Yeah.
That's even more courageous.
Yeah, I studied psychology. So naturally, my underlying topic is also psychological. And what I'm trying to find out is are registered reports an effective method to counter p-hacking? So first, this integrity problem came into my mind when I was studying, I think in my second year psychology, when in one subject, a study was introduced that a lot of our current studies in psychology can't be replicated. So why? Yeah, 61% of psychological research can't be replicated, which is a little bit different from the predicted 5% with a clause of sufficient power, of course. So there seems to be a small problem in our scientific understanding or meta-scientific understanding. Subsequent research coined the term researchers' degrees of freedom, which are basically all the decisions that the researcher will do during their research, not before. And this opportunistic use of these degrees of freedom increases the chances of finding false positive results and overinflates the effect sizes found in the first place. Richards, in his study, found 34 items of potential degrees of freedom in a research, which is quite a large amount. If you think about it, 34 decisions that a researcher can make to obtain statistically significant results. And the subsection of these potential degrees of freedom is are related to data analysis and data eligibility questions, and it's called p-hacking. So basically all the occlusions or exclusions you do with your data during your research can be considered p-hacking. So these potential degrees of freedom maybe wouldn't be a big problem at all, but there is an incentive to actually obtain those significant results. And this significant results. This pressure is given by the journals, and to me, it made the most sense to understand it through the evolutionary maxim of survival of the fittest. So the journals are in a competition for people to buy them, for researchers to want to publish in them. So a game of survival of the fittest gives perverse incentives to researchers to use their degrees of freedom in a bad way, essentially. Also, another side of this, which it brings about, is publication bias, that most of the published results are significant. And the flip side of this problem is that the results that are not significant will be just entered into the file drawer. So they won't be seen at all. So after identifying the possible underlying problems, a solution was proposed, so-called register reports. Register reports are essentially pre-ready research reports which are sent to journals to be reviewed and then decided upon if the study will be published or not. So the goal here is not to publish significant and interesting results, but rather to evaluate the report and then say if the report and the methods are good enough for the study to be published. This incentivizes p-hacking and motivates scientists to improve better guidelines. Here you can also see a small figure that the registered reports would be the stage 1 peer review, and the stage 2 peer review would be after the completion of the study and before publishing. And the stage 2 peer review is what normally is done currently. So how do we know if registered reports are actually a good method against p-hacking? For that, Simonson, Nelson, and Simmons proposed a statistical method called the p-curve. A p-curve is a distribution of statistically significant p-values. And this is important because this allows us to avoid the effects of publication bias in the sample, because we don't need other p-values which weren't significant. And the p-curve estimates the evidential value of a meaningful set of studies. And the evidential value is said to be in a set of studies when p-hacking can be ruled out as the sole explanation of the results. So it's more inferred, not directly seen. The evidential value is estimated by the skewness of the graph. Essentially, when there are more p-values distributed near the 0.05 than the 0.01, that would equate to the left skew, and vice versa. So the p-values more around the 0.1 than the 0.05, sorry, would mean a right skew distribution. The three statistical tests are used to evaluate the evidential value, are done for, or I'll explain the underlying logic. So the first test for the right skew. This is how probable the curve was if the null of no effect is true. So if pretty straightforward, if the result is statistically significant, it means that the result isn't due to randomness, and the right skew means that there is a strong evidential value in the set. A second test is a test for a flat right skew, which means that if you reject a small effect in favor, significant result in this 33% power test mean rejecting a small effect in favor of the alternative hypothesis of no effect. So if we reject this, we can say that the alternative hypothesis is true of no effect, because the alternative hypothesis of the big effect we already tested for. And the last test, which is the power analysis, is roughly how much you can rely on the results of the p-curve. This was maybe a little bit abstract, so shortly what Simonson, Nelson, and Simmons did in their study as well. On the left, you can see a left skew, and on the right, you can see a right skew. They compared two groups. For the left group, they added some exclusion and inclusion variables that they suspected indicated p-hacking, and apparently that's what they found. And on the other set, they did the opposite. Yeah, you can also see the underlying three statistical results I talked about before. But as you can see, the third test in their previous versions was a little bit different, and that was directly testing the left skew, but now it's replaced with a power test. Hopefully after all of this, my study aim makes a little bit of sense, that I'm trying to investigate if registered reports are an effective way to counter p-hacking. I'm using p-curve because to me, it seems a very good way to avoid publication bias, and additionally, an interesting way to test if a set of studies has evidential value without actually going into the original data. And to accompany my study aim, I have two hypotheses related to the two curves. The p-curve associated with the registered reports has a significant result for a right skew, so it has a strong evidential value, and the p-curve associated with C group has a significant result for a flat right skew, expected at 33% of power. So meaning that we accept the hypothesis that there might be some evidential value, but to be sure, additional research needs to be done. Because a weak right skew could have multiple reasons: a small true effect, a noisy estimate, low power, or just different manipulations of the variable. Now, to answer my questions, I devised a quasi-experimental design because I don't actually manipulate any variables. Since registered reports are mostly applicable to confirmatory research. I'm doing confirmatory research. My independent variable is publication type. It's categorical and nominal, so registered reports and normal publication. My dependent variable is categorical and ordinal, and the three levels would be strong value, not sure, and indication of p-hacking. So to get my set of studies, of course, I need to have some inclusion and exclusion criteria. So the inclusion criteria is the psychological research and confirmatory psychological reasons due to the nature of registered reports. And it's only applicable to experimental research because going through the literature, I found that observational research has some problems with the p-curve. So to have maximally valid results, I decided to only include experimental research. Also, the p-value itself has to be constructed on a continuous dependent variable. And if it's not, if the variable underlying the p-value is not continuous, then the statistical analysis gets a little bit harder, and I should include Monte Carlo's methods. I don't know how much does it ring a bell to you, but it's a little bit difficult for my education right now. Also, there are a couple of inclusion criteria for the p-values, because I can't really select all the p-values I can find in the studies. The p-values have to have uniform distribution under the null. They have to test relevant hypotheses, so a meaningful set of studies. And of course, they have to be statistically independent. Otherwise, they would start to confound. My exclusion criteria, the biggest one I would say is that I can't use journals that only publish, for example, registered reports, because my matching algorithm, I aim for a more naturalistic way of matching. And I guess I will get to the matching algorithm a little bit later. And another exclusion criteria is simultaneous recording devices, for example, like fMRIs, because when you do fMRI research, you can get the results and then analyze all the voxels you already got, and then attribute those to your question. So it resembles more like exploratory research than confirmatory. Yeah. So after making sure that I have the studies match my criteria and the p-values match my criteria, I also need to do 5 additional steps, which were advised from the authors of the p-curve to standardize the process and maximize the validity of their method. So shortly, I have to identify the hypothesis and the study design. I have to find the statistical test, report it, recompute it just in case, and then report the robustness results. And the robustness results basically mean all the other statistical tests that were done to test the same hypothesis. And now the matching algorithm. Since the registered reports are still quite a novel feature, and I would say not widely used, since there are only 190 studies in the Center of Open Science database, I found. So the first step would be to identify the suitable p-values for the p-curve associated with registered reports. Now, when I have the p-values, I will find the studies they appeared in the journal they originally appeared in. And then the article will enact as a center. And firstly, I will take the next article from the registered report article, and I will see if it matches my inclusion criteria. If it does, then I will match it to the registered report's p-value. If it doesn't, then I will take a previous one, previous to the registered reports. If that matches, I will take that one. If that doesn't, then I will take the second next one. So in the sense of I'm moving further away from the center, which is the registered reports article. After identifying all the necessary, well, all the available p-values, I will insert them to a p-curve application, also provided from the authors of the p-curve. That will generate me 2 p-curves. Each of them will have a set of statistical analyses, which you can also see in the slides. The binomial tests compare the observed proportion of significant results that are in the sector of 0.01 until 0.025. Maybe it was a little bit confusing. The binomial test compares the distribution in the 2 sectors of the p-curve against the null hypothesis of a uniform distribution. The continuous tests are obtained by computing first how probable it is to find a p-value as extreme as found, and then converting them into C-scores, then aggregating them, and then, if I'm correct, doing a square root of this aggregate, and they will end up with a p-value. And roughly speaking, this should equate to the Stu-First method. You can see under the continuous tests as well. Shortly about the limitations about my study. They are mostly related to the limitations put forward from the p-curve and the registered reports. For example, only confirmatory research. I only use continuous dependent variables underlying the p-values, and only experimental designs. And actually the experimental designs I feel might exclude the biggest amount of studies in the end. And to end it all off, I have a couple of open questions as well. So firstly, is the p-curve a valid measure of itself? Should I?
No, just finish your last sentence. Yes, I'm
Okay.
just starting my microphone, sorry.
Yeah, no problem.
I don't want to interrupt you. You're almost done.
Almost, yeah, 2 sentences. Yeah, and also, is it an accurate measure in the sense of, can the p-curve accurately distinguish between the levels of the dependent variable? Can it accurately say that I have strong evidential value, or am I being p, or were the results p-hacked? And also, maybe to some mathematically minded people, is there a difference between the power analysis and the test for left skew? The difference you saw here, the power analysis, and here, the third test for left skew. They interchange that, and yeah, that's it. Thank you for listening.
Well, thank you very much. Maybe stop sharing your screen, Andreas, and then we can see each other a little bit better. Thank you a lot. You really did great. I like your presentation. You only lost me in the penultimate slide, but that will be more clear when we discuss the stuff, and it's stupidity from my side, most likely. Danielle, the floor is yours.
Right, yeah, thanks, Andreas, for your presentation. So I think that what we're seeing now is an interesting development where data scientists are taking a look at how well certain proposals that have been put forward in the past actually work out in practice. So that's a very important step, because in some sense, people are strongly recommending, but maybe even in some way starting to force people into certain ways of working based on the start, basically, hypothetical ideas of what would improve the field, or maybe things that would improve the field in theory. But if everything worked fine in theory, then we wouldn't need registered reports to begin with, right? So the question, I guess, that underlies this research is whether we get the benefits from registered reports in practice. And that's a very important question to have clear, right? What are the results of introducing this? I think that we're starting this research off really early. So we have a very small set of studies available, a very diverse set of studies. So it's good to take a look. We probably will need to keep examining and evaluating this result as we go along. That also leads to some of my questions. So first of all, Andreas, this first thing that I mentioned, that we have a small set of studies available. Do you think that it could be the case that there's a specific group of people who are now in your database, people who are embracing these registered reports very early on, that might show, even if they show nice results, might not generalize to the people who will be, let's say, forced to use registered reports in the future, or maybe even few forced. I don't think they will be forced, but few forced. So are these, is there any indication that these are the do-gooders that, didn't even need the registered reports, maybe?
Andreas, you want to respond? And for the others, when you want to add to the discussion later on, please raise your hand in the list of participants. That's most easy for me. Andreas.
Yeah, that's a very good question. And I guess it boils down to the fact that are registered reports hackable, in the sense that does your intentions play a role to, like, when you're doing registered reports, do your intentions to do good science play a role, or are you forced in no other way? Like, let's say I'm a very, I have a good example. I'm Philip Zimbardo. I'm not a very good scientist. And I use questionable research practices. If I would be forced to use registered reports, would that change my ability to obtain false positive results or not? I think it boils down to this question. And I think it's very hard to answer in statistics, because it more relates to the validity of the methodology itself, maybe. That's what I thought about.
About the results, so I think I agree a bit with Lex. So I see the results of the analysis you've performed, and these are, just to clarify, the results for the registered reports, right? Or are they for all of the studies together?
Currently, I haven't really taken any, I haven't collected any data yet.
The results are hypothetical results on this slide, you mean?
Yeah, the hypothetical results on the slide.
Okay, okay, good, good.
Yeah, sorry, maybe I didn't clarify it enough, but I brought it out especially because there is a difference between the power and the third test.
Okay. I understand. I understand.
This helps me as well. Thank you so much. And you're going to produce later on graphs like in the beginning of your presentation, most likely, because I was waiting for these. Yeah,
but since I'm practice what you preach in some sense, so
yes,
I haven't started the data collection.
All right, this is your phase one peer review. Yeah. All right. So I have another question, a bit related. So if there are very good people who take up registered reports, right, then it's difficult to see any bias because the people who would be performing sort of biased analysis are not in there yet. And a second consequence of this might be in the journal selection process. Now, I understand your choice to match clearly. You know, I mean, there is, of course, a strength in closely matching the studies by picking them from the same journals. But I think there might be a collider in the design, in the sense that if only very good journals that already have very high standards and that value transparency a lot choose to start incorporating registered reports as a submission format, then these will publish very good work anyway. And I mean, let's just have another hypothetical example of a journal in this case where there might be more problems in the way they work. In my field, you have the Journal of Personality and Social Psychology. And they took a very long time to even consider introducing something like a registered report, even though this is the journal where Daryl Bem published his pre-registration studies or his precognition studies and things like that. And I think I don't know how many they have published, but they will not be very big in your database. Whereas they might be an important sample to look at for the control condition, for the more problematic studies. So if you only limit your analysis to journals that have registered reports, these might just be pretty good journals to begin with. Is that a problem, possible problem?
That's a very interesting point, but isn't to pick a little bit apart, isn't the idea still to keep all the other variables besides the publication type the same? So in a sense that,
well, I mean, I would guess in designing research, there's a trade-off of different factors. There are different sources of possible bias and there are different sources of control. Your choice controls the sample in the sense that it makes them most similar. But in doing so, you could also have a confound in like a collider bias. So you're selecting only let's say the best students, right? That's another example of collider bias. If you only look among the best students, there are no correlations between how much they study and their grade, for example. But if you look at the entire population, you see a correlation and you're maybe missing out on a difference because you're already selecting on really good studies because and I think this is partly true. There's definitely, I would say there's a strong correlation between how good a journal was, how much the editors care about transparency, and how quickly they introduced registered reports. So it's not unlikely that there is some real confounding going on there. Yeah, it's just something. Yeah.
Sorry, I understand your point that that they already, from where I select, are already the high apples or the.
Yeah, there's a possibility. I think I can't come up with the entire list, but I think it's quite likely. Even to the extent that you're also excluding journals that only have registered reports. Well, that makes sense, of course, but these are journals that are started like in social psychology. You have comprehensive results in social psychology, which is a registered report only journal. So everything they've published so far, I would hope, is not so much behacked. Yeah.
So to try to recap it, you would say that the homogeneous sample would attenuate the differences.
Yes.
Okay. I think that's a very good point to discuss even in limitations or in discussion to.
That is one approach. Another is to give up the close control between the control and the experimental group and just accept that you're not keeping everything similar, but you're sampling from the entire population and not a subset. Yeah, it's, you know, research is always difficult. There's never a perfect thing that allows you to do everything. Yeah.
That would introduce a little bit of the, where would I draw the line between the p-values I could gather from the normal studies as well, because I could have a very powerful p curve from the normal studies.
Mm-hmm. Mm-hmm. Yeah, no, it's difficult to predict. I agree. It's not easy, but there is a choice, I think.
Wonderful. You want to pursue, or shall we move on to the others and then come back to you if you want, Daniel?
That sounds perfect. Yeah.
You're part of the group, so you can step in any moment you'd like. So please raise your hands if you like in the participants list. And Guy wants to ask something. Maybe I can ask one quick question to you, Andreas. Are you going to register your report?
Yes.
Right. I would be disappointed if not.
Yeah, I would be too, to be honest. And hopefully we can do it on Friday with Bram. But if not, then very time soon.
Great. Over to you, Guy.
Yeah, just one addition to the points which Daniel made. Of course, this is probably a positive selection of journals, but if you even then would find differences, that would of course be interesting. So I would say go ahead, don't change your design. I also say that as a supervisor in general, it's always good to go ahead, but take into account that if you find differences, you really have a good story. And if you don't, well, then you just have to say that Daniel has to do the next study.
Why not?
But I really like this idea, by the way, yeah.
That we need more registered reports.
Yeah, we need to work on that. And Daniel was too humble. Maybe we should make it mandatory at the level of funding agencies, because there seems to be a huge reluctance to engage in registered reports. And I can understand that, because it's hitting you at the moment that no investigator has any time to wait for reviews. And that makes sense, waiting for reviews to improve your study.
Well, my question is, would it be reasonable to make that change in a doctorate level? For example, whoever does a doctorate would need to follow the registered reports guidelines?
Well, I honestly don't know. I believe in my world, most studies are funded by funding agencies, and they have the power to make this change, not as the only party, but as the most important party. PhD theses are often done on granted proposals. And when part of the grant proposal is that you are allowed to spend your first 6 or 7 months on getting the registered report done, then the issue is solved. Do you agree, Daniel?
Yeah, and actually we had a meeting a couple of weeks ago with non-profit funders in Europe. So this is the Volkswagen Stiftung and other similar parties that fund scientific research. The question is, what can funders do about the replication crisis? And there was a bunch of speakers, like 5 or so, and I think everybody of them mentioned, well, you could require that everything you fund is published as a registered report. And they sounded like, they thought it was not crazy. So so it might even happen for some smaller funders which are a bit more flexible. NWO takes forever to do anything. So if NWO does this, it will take a decade. But these small funders also really control their own resources, their own funding. They very often have societally relevant research that they fund. They don't want to waste their money. They don't have a lot of it. So something could happen, I think.
Makes sense. Any other questions? Please raise your hands or just speak up. Noemi.
So I'm not a pro at all in this topic, but you did a very good job. But I have a question for you. and it may not make sense, so bear with me. When you're looking at the different journals and looking if there's a difference and possible p-hacking, are you making a distinction between open access journals and non-open access journals? And the reason I ask is because possibly non-open access journals need more readers, and they may be more biased in the articles that they select versus open access journals.
That's a very good question. I don't really discriminate between the open access and closed journals, but my matching process starts with identifying the suitable p-values for registered reports in a Center for Open Science database, which is a closed database, and it has currently 190, at least a month ago. So firstly, I would take the studies there, and then I would locate the studies I found in that database in the journal they appeared in. So that would be the how I get to the journal, not by if it's open access or closed.
Yeah,
if that answered your question. Okay.
Yes. Any other questions? Bram.
Yes.
Well, you can ask a question, or and later on, Andreas can ask you to answer it yourself because you're involved.
Well, yeah. Well, thanks first for the presentation and also for the interesting discussion after that. I think what Naomi just mentioned is actually a good idea for another research topic in which you could check if open access indeed leads to more p-hacking. But yeah, that's not part of this research, because really the idea is to check if registered reports are efficient in avoiding the p-hacking and show more evidential value. I was very interested in this discussion of what is the best control group of articles. And yeah, I think it's a good point. It might be biased in a way. So we want perhaps find a real clear difference. And I think this was already one of the worries we had when we were going through the literature, because we have only not only one topic or one hypothesis that we are creating the p-curves for, but a whole bunch of different hypotheses, some of which may be true and some of which may not be true. So we have a very heterogeneous set. And I think that already makes it a bit more difficult to compare the p-curves in the first place. But yeah, this was, I don't know a way around that, but I guess this adds to the difficulty to find a difference. Maybe I have a question for everyone in the group. What would be a good way to increase the chance of finding a difference? Because in the example you gave, Andreas, you showed a study by the Simonson in which they compared a group of GPSP articles with covariates with another group of articles without any covariates. And their assumption was if you add covariates in an experimental design, that may be a sign for p-hacking. And indeed, they found a very strong right-skewed curve for those articles with covariates. So that is a very interesting approach, I think. And I was wondering, would it help also for our design to add that as an inclusion criterion, only articles with covariates or something like that?
Interesting question. Who's willing to answer it? Danielle, maybe you can also reflect on what your PhD student did, because she had another way of matching in a recent preprint, didn't she?
Yeah, a couple of things. So first, the strongly p-hacked p-curve in the Simonson article is indeed because these are studies with covariates, and the idea is people sort of mess around with their analysis and throw in a covariate, and that will make it significant. We tried to replicate this in a slightly different time zone, and it didn't look that bad in a slightly different time zone. It didn't look as good as well, but okay. And this brings me to another point that I think is important. So yeah, my PhD student Anne Scheel just had a paper accepted in AMPS where we compare just this, how many registered reports yield positive results. So the main prediction is significant or not. So it's not about a distribution of the p-values, but it's just pure the number of supported findings compared to the traditional literature, the normal standard non-registered reports. And the difference is huge. Like in the normal standard reports, 96% of findings are statistically significant. I think there's a paper by Brian Nosek's alter ego, Irina K. Bones. He publishes sometimes under an alter ego, which is maybe a fun fact if you didn't know this. And the title of the article is "We Knew the Future All Along." And he makes the joke like, well, if 96% of our findings are significant, let's just skip the data collection, right? Because you can just say, this is my hypothesis. 96% of the time, our field is just correct, so let's skip it. But it drops to about 46% or something in registered reports. So there are definitely many more null results. Now, an important thing that she learned in this project that is going to be relevant for your project is it is very difficult to pinpoint the key hypothesis. So to find the key p-value, and this is surprising because our ideas of a registered report is somebody has a perfectly written up proposal. It's super clear. They're going to do this sort of almost randomized controlled trial kind of test, and we'll find this p-value easily. And what she found is very often you have to rely on a statement like, well, so this, hinting at 7 tests that were done before, this supports our hypothesis. And then she says, well, okay, let's code it as this clearly supported their hypothesis or not. But it's very often very difficult to say what is the key p-value or the key test. So, and this brings me to my question, sorry for taking so much time, about how can you have this p-hacked version of the Simonson thing? I don't think the covariate will happen very often, but I have a prediction, and maybe it's interesting. I think people move their p-hacking to the more exploratory part of the register report, which is still allowed, of course. So if you would take, let's say, the first exploratory finding, or maybe even the most important exploratory finding, maybe that is where they do the p-hacking. And I wouldn't even be surprised if somewhere in the abstract, somewhere, they actually give a lot of weight and they discuss this sort of exploratory p-hacked finding anyway. They try to sneak it in somewhere, whereas the real clean pre-registered prediction is still nicely reported. It is now available, but in the discussion, they will go on about this other stuff. So if you want to find something p-hacked, I would focus on those, the first exploratory report. That would be a very interesting comparison, even in strictly controlled register reports, I think. Yeah. Maybe.
Yeah. So you have an internal control group then, in a way.
Yeah.
Yeah, that makes a lot of sense. And well, and your view on humanity in general and researchers in particular is rather black, isn't it?
I'm very optimistic in many ways, but reading the literature carefully doesn't always leave me very optimistic, I have to be honest. So, yeah.
Yeah, I can imagine.
Actually, the open science collaborations I referred to, the 2015 article, came with similar results, that 97% are positive results confirmed. And then they replicated the 100 studies, and they only found, I think it was 37 or 39 studies could be replicated. That's how I got my number as well. And that's a very interesting comparison for your PhD student, in a sense that if the replications were done nicely, it dropped close to the level of what the registered reports usually find. Yeah, maybe.
Yeah, true.
Yeah, really interesting. Who wants to raise another issue or question or make a remark or whatever? If not, you want, Andreas, please go ahead.
I had another remark that you raised concerns over selecting the correct p-values and from the studies, and actually the Simons, the same authors of the p-curve came out with another study, which was kind of like addition to the first one, where they went over how to avoid these mistakes of choosing the wrong p-values. So reflecting on what you said is, yes, it's a big problem. They have tried to make the problem go smaller, and I will, of course, do my best, but sometimes it might be unavoidable.
Yeah, there's a bit of a difference in the literature. So they often look, like Yuri Simonson and their colleagues look at decision-making research, which is often experimental and very simple, like very simple designs, 2 conditions and t-tests and all that stuff.